All right, welcome to multiplying fractions. Let's get started. So we're going to start with the visual representation of these. We have 3/5 and we're going to multiply it by 6. Now, we're going to do the first one two ways, and then the rest we'll just do one way. So if we look at the first way of doing this, on each one, we have, 3/5. And if we color that on the first one, and then we do it 6 times, it's going to take us some time to count exactly how many fifths we have. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So we have 18 fifths. Now, we love improper fractions. We do not want to take it to mixed numbers. Do not take it to a mixed number. The only time you're going to have to take it to a mixed number is if they give you like a multiple choice answer, and that's the only way the answer is offered to you. But ultimately, it would be really hard to tell from a pictorial representation of something that is 18 fifths, looking at it. And ultimately, like if we order pizza, you're not going to say like, oh, I need 18 fifths of something and that's how it's going to be. Like, unless you have like a pizza pie of pepperoni and sausage and pineapple and all these different flavors, most likely if you get 10 cheese pies, people open one and start eating, and then like when a box is empty, they go move to the next one. They don't take 3 out of 5 slices and then open the next one and leave 2 in there, right? So how we really, want to do this. Oh, I'm losing my we love improper fractions, but we really do love improper fractions. That's not a lie. Is we want to say, okay, there's my 3/5 original 1, and now we're going to multiply that by 6. Well, here's my second one. Here's my third. Here's my fourth. Here's my fifth. And here's my sixth. That's easy. That's very easy to see that you have 3 and 3/5, which very quickly can get you to the fact that you also have 18 fifths. Okay? And I got to 18 fifths by converting from my mixed number to my improper fraction. And again, what did I do? I just took that 3/5, my original 3/5, and I kept adding 3/5 to it. Now, it might have been split between 2 of those circles or 2 of those fifth representations, but ultimately that's it. Each fifth counts the same whether it's in one or the other. Okay? So same thing, if I have 1/3 and I'm multiplying it by 4, well, there's 1, there's 2, there's 3, there's 4. I have 1 and 1/3, or 4/3. Those are equivalent, right? 1 is a mixed number, 1 is an improper fraction. If I have 1/8 and I'm multiplying it by 6, there's 1, 2, 3, 4, 5, 6, right? Now, here we go. We don't have a mixed number. We actually just have 6/8, which simplifies. They're both even. We can knock it down to 3/4. And that's easy to see. If we have quarters, isn't it easy to see that we have 1, 2, 3, 4 quarters of that circle, and we have 3 of them filled. Okay. Here's 1, 2, 3, because we have 1/3 times 3. And what do we really have? We have 1/1, or just 1, a whole circle. Okay. 2/8. So this is interesting because most of these have been 1, other than that first one. But remember, we color 2 at a time. So 2, 4, there's 3 of the 2's. Oops. 4 of the 2's. 5 of the 2's. 6 of the 2's. 7 of the 2's, right? So 2, 4, 6, 8, 10, 12, 14 eighths, which really gives us 1 and 6/8, or 1 and 3/4. Again, looking at this as quarters, we have 1, 2, 3 out of 4 of those quarters. So what are we really doing when we're multiplying? What are we doing without this picture if we take this picture away? Well, what we're doing is we're taking the numerators and we're multiplying it by a numerator, and we're taking the denominator and we're multiplying it by a denominator. Now, this is different than when we added, because when we added or we subtracted the numerators, but we did not touch the denominators, okay? This is something you have to remember, because when we put this all together, it's a difference, right? It's a change. So with multiplication, you multiply the denominators. You do change the denominators, so the denominators do change. All right, we multiply straight across. Okay, so what do I mean by that? Well, we've done this before. We did this when we were looking for common denominators. So you're going to be like, I feel like we did this. We did this already. Okay, so we're going to take the top, we're going to multiply the bottom, we're going to get a top, and we're going to get a bottom, and we're going to have a new fraction, and then we're going to have to simplify it. So 1 times 2 gets me 2. 3 times 5 gets me 15, and we have 2/15. We have to ask ourselves, does it simplify? In this case, it does not. So our answer is 2/15. Now, if I have an exponent, we can also see it as an exponent. Remember what an exponent means. It means you have the base, you have this number. I have this number. This many times. That doesn't look like that word. Okay. So if I have this number this many times, this means that I have 3/4 times 3/4. And then I'm going to do the same process I just did. I multiply the tops, I multiply the bottoms, I get a top, I get a bottom, I have a fraction bar in the middle, and what do I get? I get 3 times 3, which is 9, I get 4 times 4, which is 16, I make sure it doesn't simplify, which in this case it doesn't, and I get 9/16. And I'm all done. All right, let's look at the next one. I multiply the top, I multiply the bottom, I get a top. Oops. I get a top. I get a bottom. I have a fraction bar. I get 7 times 1, which is 7. I get 8 times 2, which is 16. I make sure it doesn't simplify, and I'm done. I write this out as 1/8 times 1/8. I multiply the top. I multiply the bottoms. I get a top. I get a bottom. I get 1 times 1 is 1. 8 times 8 is 64. I can't simplify, so I'm done. I multiply the top. I multiply the bottom. I get 35 over 32. I can't simplify, and I'm done. Now, F is where they throw a little bit of a curveball at you because ultimately it does not look like you're multiplying two fractions, but you can make any number into a fraction. And the way you make any number into a fraction is by putting it over 1. So what do I mean by that? 4 doesn't look like a fraction, but you can make it a fraction by putting it over 1. Okay? So now multiply the tops, multiply the bottoms. 10 times 4 is 40. 3 times 1 is 3. You have 40 over 3, which doesn't simplify. Once again, it came up in letter E and letter F. Do not turn things into mixed numbers. Leave them as improper fractions. Okay? Leave your answer unless it specifies otherwise, leave it as an improper fraction. It's going to make your life way easier, and it takes out one extra step where you might have human error, which we are all susceptible to. All right, so here's where again we were heading towards this, and we gave you a taste of it, but here it really, you get more practice of it. We're going to put the 18 over 1, and you're going to do the same thing. We multiply the tops, we multiply the bottoms, but here's a trick. So the trick is if you can simplify corner to corner beforehand, you can simplify corner to corner before multiplying straight across. Okay? And what I mean by that is you can divide out a factor. Any common factor. So here, if you look corner to corner, 18 and 9 have a common factor of 9. So you can do 18 divided by 9 is 2. 9 divided by 9 is 1. So rewriting this problem, you actually have 2 over 1 times 2 over 1, which then multiplying straight across, you have 4 over 1, which just equals 4. All right, so letter B, first step, always put as an improper fraction. So here we're going to make this 17 over 2 times 1 over 4. I can't do any corner to corner cancellation or simplifying, so I'm just going to multiply straight across, so I get 17 over 8. I can't simplify, so I'm done. So letter C, I have 9 over 10 times 15 over 7. Here, I can simplify the 10 and the 15. They have a common factor of 5. So 15 divided by 5 is 3, and 10 divided by 5 is 2. So if I rewrite my problem, which you don't have to, I just sometimes think it helps with the clarity of how the problem looks, I have 9 over 2 times 3 over 7. If I multiply it straight across, I get 27 over 14. There's no like terms, so I'm done. Now this one, I have 3, which is fine. It doesn't, it's all multiplication, so I just multiply straight across, but I do need to turn them all into improper fractions before I start. So I get 25 over 3 times 3 over 10 times 5 over 6. So if I color code what I can simplify the 25 and 10, and I simplify the 3 and the 3. I can probably simplify more, but I'm going to wait. I'm going to do it one step at a time. So 25 and 10 have a common factor of 5. So 25 divided by 5 is 5, and 10 divided by 5 is 2. 3 divided by 3 is 1, and 3 divided by 3 is 1. So right now I have 5 over 1 times 1 over 2 times 5 over 6. Okay, so I can't simplify the 5 and the 5 because they're both on top. And I can't simplify the 2 and the 6 because they're both on bottom. So you can only simplify if one's on top and one's on bottom. So now I'm just going to multiply straight across the top and straight across the bottom. 5 times 1 times 5 gives me 25, and 1 times 2 times 6 gives me 12. And nothing else simplifies, so I am done. All right, so a couple that are a little bit more tricky. We have 1 1/2 to the 3rd power. So first thing I'm going to do is I'm going to make it into an improper fraction. I have 3 over 2, and this is to the 3rd power. Now, if you look back at those notes, I said it's this number this many times. So that means I have 3 over 2 times 3 over 2 times 3 over 2. So if I just start with this one, I have 9 over 4 and then times 3 over 2. And I go straight across again, so I have 27 over 8. And I'm all done. Now this, I'm going to first do the part to make the second piece an improper fraction, so I get 7 over 3. And then I'm going to rewrite this to be a multiplication problem because, again, I have this many times. So I have 1/2 times 1/2 times 7 over 3. And I'm just going to work left to right. So 1/2 times 1/2 is 1/4 times 7 over 3, which gives me 7 over 12. And I'm all done. All right. Work on this, practice with your independent, and I will see you soon.